Alright, so this is my video on related rates. So I figured that the best way to explain it is through looking at the problem first, and then I can give you a quick guide on what to do through words. But if you want to see me solve it out, I'm going to show all the steps. It's going to be later in the video. But let's start by reading out the question. The top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? So let's start by doing this. This is a basic 6-step guide on what you need to do. Identifying the variables, labeling the quantities on a graph, identifying the rate of change that you need, writing down an equation related to the variables and the graph and the shape, differentiating the equation with the respective time, and then plugging in known values for the variables, and then finally solving. But basically, after that explanation, I figure it's better to explain it like this. So we're going to be using a right triangle for this equation. You could use other shapes with other equations and other problems, but you would use a right triangle in this case because you're using a ladder, a vertical wall, and the ground. And what related rates need you to do is whatever shape that you're going to use for the problem, you need to define everything that you know and make that a constant. And with everything that you need to know, you need to make that a variable. All right. So we know that our hypotenuse, the ladder, is going to be 25 feet. Oops. That is going to be a constant that will never change. So that will be a whole number. This is going to be our x value, and this is basically what we're going to be solving for, or the change of this. And this is because it's asking for the bottom of the ladder, which is down here, and the wall. So this is our y, and this is basically going to be from the top of the ladder to the wall. And with other problems, you could easily define other things, such as maybe this angle being theta, or this being the right angle, or this could be theta again. But the point is that with different problems, you're going to be defining different things, and the idea is that you're going to be finding the change through implicit differentiation. But let's move on to step 2. So now that we have our triangle and it's fully noted and shown whatever we need to use, let's start by writing down everything that we know about this triangle, or the givens. So we know that let me just make this box a little bit bigger. So we know that our hypotenuse, our ladder, is always going to be 25 feet. Just define that. We just defined that we have a right triangle, so we're going to be using the Pythagorean theorem since all of our variables are related in a Pythagorean theorem equation. So if you forgot, for this case at least, it's going to be x squared plus y squared equals 25 squared. And we use this because we're trying to find the relation between x, y, and their changes respectively. But talking about the rate of change, we need to find out we need to use a change of y, and that is going to be 3 feet per minute. So we can write that as the derivative of y over the derivative of time is equal to 3 feet per minute. And this will be constant for the whole time the ladder is sliding down, even when the top of the ladder is 7 feet off the ground and we need to find the rate of change. So we need to find, speaking of, the change in x, or the derivative of x over the derivative of time, when the top of the ladder, or y, is equal to 7 feet. So now that we have everything defined, Let's start by actually using it in the problem. So now that we have everything we need to pretty much find out what x is, we need to find out what x is when the top of the ladder is 7 feet off the ground. We need to find what x is because we need to use that for our derivative equation. So we can start that by putting the equation forward. So now we have x squared plus 7 squared equals 625, and this equals 49 once you square it out. And after solving for the equation, solving for x, we find out that x is equal to 24. So now we know that x is equal to 24. We can write that here. Oops. That's good enough. So x is equal to 24, y is equal to 7, and we have our 25 feet. So now we're going to be dealing with the rate of change of, since we're dealing with it sliding, and it says right here, we're going to need to find the derivative of our Pythagorean theorem equation. So we can bring the original equation here that we haven't plugged anything into it yet except for the hypotenuse. Y squared equals 625, and let's go ahead and find the derivative of all of these variables and whole number. So we're going to be finding the derivative with respect to time, or d over dt. And this is where our implicit differentiation comes from. Now, if you're asking why we're using d over t, is because, once again, we're going to be using the rate of change. And since it's changing with respect to time, since we have minutes, we're going to be using time. So since it doesn't have a denominator of dx or dy or any of the variables that we have, to be more specific, we're going to be using implicit differentiation. And how you do that is, at least with this one, we find a derivative of the original f of x or original y or whatever. So that is going to be 2x times dx over dt for our first value. We repeat that for our y squared. Sorry, let me just make this a little bigger. Plus our 2y times dy over dt equals 0. And it's 0 because you can't find a derivative of a whole number, since it's just a point on the graph. It has no slope, it has no differentiation. So now that we have our equation, we can finally start to plug in the values that we know. So we're going to plug in 2, and our x value, which we solve for, is going to be 24. And since we don't know our dx dt, we're going to be leaving that still. We bring it down, dx over dt, plus 2. We fill in our y value as 7, since that was given to us in the equation. When the ladder is 7 feet from the ground, we're going to be solving for that point. And we know that our ladder is constantly falling at -3 feet per minute. One thing I forgot to add, sorry. Well, two things actually. When you're doing it on a test, on the test paper, it's expected that you put the units, because the units would matter for getting all points on the test. Since these values are just measuring a distance, they would be in feet. But since dy over dt is going to be a rate, it is going to be feet per minute because it is the distance over the time. Okay, so now we can finish by making the equation equal to 0. And just so everyone knows, it's -3 because it's sliding downwards. It's decreasing. So this will be decreasing. That means that it's a negative. All right. So now that we have our equation fully fitted out, we can start to simplify. And we can do this by saying 48 feet times dx over dt plus negative 42 feet squared per minute equals 0. So, now that we have everything filled out, we can now start to solve for dx. You would do this by isolating it, and we would start doing that by subtracting both sides by 42, or well, in this case, adding. So then we can add both sides 42, and this will leave us with 48 feet times dx over dt equals 42. 42 feet squared per minute. So now we can finally finish off by dividing both sides by 48. I should probably use a pencil tool so that way it's easier to read. Oops. Okay, that'll work. So now we divide both sides by 48 feet. And then we get our answer of dx over dt equals 42 feet squared per minute. And at the bottom, we can have 48 feet. So now we can simplify, and we need to change the units so that way they're actually correct. So since we have feet squared on top and we have feet on the bottom, we can get rid of one of them on both sides or on both halves. And we can simplify 42 over 48 to finally equal dx over dt equals 21 over 24 feet per minute. Okay, so what have we done? We've pretty much taken our question, we've defined what shape or what equation we're using based off of a shape. In this case, we're going to use Pythagorean theorem since we have a right triangle that was created with a ladder, a ground, and a wall. And we pretty much started solving for variables using said equation because we are going to use them in the derivative of the equation with respect of time. So after solving this, we get 21 over 24, and this is pretty much how to solve these type of questions. Please leave a comment if you have any questions or text me or whatever. Hopefully this was clear to you guys. Thank you for having me.